Today I'm going to show you some exponent rules. This might be helpful when you're dealing with expansion questions with large exponents. So let's just recall what exponents really mean. So if we have an expression in the form b to the n, we say that b is the base and n is the exponent, and this essentially means b multiplied by itself n times. So let's just see the exponent rules. Here I've wrote 7 of them, so let's just work through each of them one by one. So the first one, if we have a to the m times a to the n, this just means a to the m plus n. So multiplication of two exponential expressions with the same base just means that we can just add the exponents. The similar thing works for division. So if we have a to the m divided by a to the n, this means a to the m minus n. So division means subtraction of exponents. And third, if we have a to the m in parentheses and then all that to the n, this essentially means a to the m times n. Note that this is not equal to a to the m to the n. This is a completely separate thing from this expression, and what this essentially means is that the top part of the exponent is worked out first. So we can rewrite this as a to the quantity m to the n. Now the fourth one, if we have a times b quantity and then all that to the power of m, we can just distribute the exponent to each of these numbers. So we have a to the m times b to the m. Note that this works for any finite number of terms, so assume that you have a times b times c to the m. We can just distribute m into each of these terms. So we have a to the m times b to the m times c to the m. For the fifth rule, if we have a power of a quotient, so we have a over b and then quantity, all that to the power of m, is just the same as a to the m over b to the m. For rule 6, we have that anything to the power of 0 is equal to 1, and that 0 to any power is equal to 0, as long as if that anything is not equal to 0. Otherwise, we're left with the expression 0 to the 0, which is indeterminate. And finally, for rule 7, if we have a negative exponent, so we have a to the negative m, this is just exactly the same as 1 over a to the m. Let us use those exponent rules to expand each of the following expressions. So for part A, we have x to the 5th plus 1 times x plus 1. Well, we can just distribute the first two terms in the first group with the first term in the second group. So we have x to the 5th times x, that will be x to the 6th, plus 1 times x, that will be just x. And then we can distribute the first two terms with the second term in the second group. So we have x to the 5th times 1, that will be x to the 5th, plus 1 times 1, that will be just 1. Or we can rearrange this in decreasing powers. We have x to the 6th plus x to the 5th plus x plus 1. The similar thing can be done for part B, so we can just distribute the first two terms with the first term in the second group. So we have x to the negative 1 times x squared, that will be just x, and then 1 times x squared, that will be just x squared, and then distribute the first two terms with the second term in the second group. So we have x to the negative 1 plus 1, that will be just x to the negative 1, and then 1 plus 1, that will be just 1. Rearranging in decreasing powers, we have x squared plus x plus 1 plus x to the negative 1. Or if you would prefer, you can just change this into a positive exponent. So we have x squared plus x plus 1 plus 1 over x, which ends this video.